First of all, thank you for having us on the program. It's a great honor to be on this kind of a program with stalwarts in air conditioning and mainly in filters, Mark Schmidt and Silva, and all of you. And our greetings from India to start with, to all the 387 attendees that we see now on the screen. And also a very warm welcome to the participants from Middle East. As you know, I have spent 25 years in the Middle East before coming back home, and I have many friends today listening on this program, and my greetings to all of them. So I will be presenting basically the designer's perspective, and just to tell you that we are now building our country. That means there are more new jobs that are coming up in India than probably a lot of the regions that are listening into this presentation today. And it's very important that we get it right. And a lot of development will take place in the field of healthcare, where air filtration is going to be a very key thing. And it's also going to be key going forward as the offices reopen. At the same time, there is a big push in India for energy efficiency. As you know, we are a part of the Paris Agreement, and we are very focused. And so we have so far contributed a lot to it, and we would not like to lose the lead that we have set up in terms of energy efficiency. So the first thing that came to me on this particular topic was, are basically energy efficiency and indoor air quality mutually exclusive? And they are not. And after having researched in detail all the good handouts that Eurovent has provided, I could say it with firmness that energy efficiency and indoor air quality also go hand in hand, and they are not mutually exclusive. So let me move forward to the slides, and let us first understand some basics of what 16890 2016 is all about. And in fact, today, this will be left to the participants, whether we could deliver it properly, whether at the end of the day it was taken home or not. We will put in all the efforts that are necessary to make the ISO 16890 the specification or the standard on filters going ahead. A little bit of historical perspective. So in India, we did have a standard some time back, and during my research, I did find out that the first person that I worked under 40 years back was probably the head of that standard. And have we got revisions? My research does not show that at this point of time. But I'm fortunate to say that the National Clean Air Program people in India are listening into this particular webinar today. And going forward, we would also be able to put in the standard as we have put in for indoor air quality, as we have put in for chillers, air handling units, so that we can keep track of the energy efficiency. So many a years back, basically, indoor air quality was related with sick building syndrome, and we worked a lot on it, basically. And then in the year 1987, EPA came in and defined the particles in terms of microns or sizes. PM1, PM2.5, and PM10 was first heard about. So where was all this coming from? Because before that, we had something like coir filters and metallic filters that wouldn't take care of these small particles. And these small particles were becoming important as the time proceeded. So it was coming basically from burning of tires, from brake shoes in cars, lead in petrol, a lot of fine particles. And this PM1, PM2.5 was sort of becoming an area of concern as time proceeded. At that point of time, ASHRAE 52 and EN 772 became the initial standards with, and the testing on that was with a single grade of dust. So once the gradation was done, there was a need for a change, and the working group 3 of the ISO TC 142 was called into action, and it devised a very detailed method of testing, and you will hear more about it from the experts in this program today. So going ahead, what did PM1, PM2.5, and PM10 do? It affected the different parts of the bodies. The PM1 reaches deep inside the lungs, the PM2.5 to the middle lobe, and the PM10, of course, affects your throat, etc. But all these things have an effect on the human body, and the WHO realized the importance of these particles, and any filtration standard that comes in must basically revolve around these particular nomenclature of PM1, PM2.5, and PM10, because it becomes easy for designers like us to understand, amongst all the other things that designers do to get their air conditioning HVAC systems right. I have to say there's lots of chill water and DX and what have we. And then when it comes to filters, one very important thing is that it should not basically be very complex. It should be something which is understood by the designing fraternity. There are times when we need to bring in experts, and they are available. But there are a lot of projects that are done in India where, basically the designer has to pitch in at any point in time, and the standard should be understandable by everyone. And that's what we saw in ISO 16890. And that's the reason I would say that this should be the standard going ahead. Okay, so recently, when we see air handling unit submittals, we find these terms EPM10s 50%, 60%, EPM1 60%, and other things appearing on the air handling unit submittals. We did a small or a reasonably good presentation on hygienic AHUs, and we found that we got many questions from the listeners asking us to go into the details of this particular nomenclature. And that is what I think we are here principally to do today. A lot of experts will contribute into it, but this is a nomenclature that makes the designer's life easy, because through this we get to know which particle size to what efficiency is being removed, and you have a gradation. So going into the details, the part E comes from treated and untreated filters conditioning with IPA streams, which has changed from EN 772. So you will hear the experts talk about it. And going ahead to the next slide. Yeah, let me go back one. Sorry for that. So when we hear about the MERV or the ASHRAE 52 filter process, the difference was that this did not have that particular gradation which comes into IS 16890. And as I understand from my reading up things, that ASHRAE is also in the process of modifications based on this particle size. Going ahead, This is a graph that we all need to understand. The blue line, which is showing on the left-hand side picture, is basically the distribution of the PM particles as we see in the atmosphere. And this has been peer reviewed several times, and it has been widely discussed. And what we need inside the hatched area is what we need in our supply air, the PM levels, in order to meet the criteria in spaces. Some of the countries like India going ahead in the ISHRE IIQ standard, we have clearly defined the PM 2.5 and PM 10 levels in microgram per meter cube of air. And we would like to see levels below this in order to classify a building as Class A, Class B, and Class C. Now, very easily, meters like this are available all across. And it's pretty simple for consulting engineers and professionals to go around now in the buildings to see what is the kind of IAQ standards that they are finally getting. So we are again talking about the particle size PM1, PM2.5, and PM10. And with the help of all the guidelines that we see that are now provided by Eurovent, uh, it becomes easy to understand the difference between EN 779 and ISO 16890 and increase the awareness on the energy efficiency of air filters. I was very happy to see that a lot of work has been done to talk about the energy efficiency of air filters, because many systems do not take this into account. So basically, what is happening is that at Eurovent certification, they have been able to grade the filters depending on the kilowatt hour that a filter consumes working for one complete year. And you will see that the gradation goes from a value of say 700 or 800 kilowatt hour for the best possible filter that manufacturers have designed to almost double that value for a lower grade energy class filter. So those who are into energy efficiency will be able to take advantage of this. And they are always justifying what is the energy saving for the good things that they have used in their systems, and will be able to bring that out in a very good manner using these particular tools that have been designed. So what it does is it provides basically a kind of an ecosystem around the product, which is very necessary uh, while going ahead to make the product tangible and explainable to the boardrooms and the building owners as to why these differentiated products have been selected and put into the design. And also going ahead, there is one point that comes to me time and time again, is when during such webinars or on interviews we find people asking if offices will go with HEPA filters very soon. Offices are not designed for HEPA filters. The airside systems are not designed for that. And they do impose a lot of external static pressure, and changing systems to get into HEPA is going, if push comes to shove, then we'll all have to do it. But basically, that's not the first choice. First, stick to the HVAC filters. If you need to take care of PM1, take care of PM1 in certain critical spaces. And thereafter, basically, we can see if we have air cleaners or other things sitting over there, which can help in removing further small particles and take care of certain critical spaces that we are seeing and requiring today. Another good thing that you will hear about is that the famous blue line that I showed you in that graph, it can have uh, certain variations. And I was very happy to see this ODA 1, ODA 2, and ODA 3, which probably Mark will go into in detail. And also uh, what kind of supply air levels SUP1 to SUP5 we require in industrial spaces and in the other what we call the comfort world, or the hospitals and data centers, warehouses, etc., in order to achieve the indoor air quality levels that we are trying to achieve. And now the filters get nicely tied up with the outdoor air quality, indoor air quality, a tool to select the correct filter with the right pressure drops and have the right amount of energy being spent because of the pressure drop in the filters. And they reflect a different value going from, uh, I would say, the everyday filter to the highest quality and the highest priced filter, um, and it shows the energy efficiency difference. And that is going to be very helpful going ahead in keeping basically filtration levels and energy efficiency going together. So you will hear, and this document, as Marcus said, is available. Go through the detail. It's a very, very important document for HVAC engineers. Some of the service people would also be joining in, and they are used to this nomenclature, the F7, F8, F9s, and how would they go ahead with replacement of filters. This has also been provided in guide documents, and a lot of the other systems have also written about it. And you would not fall short of that as far as replacement filters are concerned. And I understand Mark is going to take this further into one stage and two stage filtration, and how you would put in your first stage and second stage. Uh, ECC, or Eurovent certification, has come up with a very good program, ECP 11 FIL. It's kicked in 2020. We need to make it a success, basically. And it's very important that the filters deliver what they state, and that is what you get through certification. And you can be assured of the quality of filter that you are putting in your system. And then it's a job to measure the outdoor PM levels and the indoor PM levels, tweak things, do what is necessary, and get your indoor air quality levels right at the right energy spend. So filters go into all these areas. They go into shopping centers, they're going into high-end offices, they are going into healthcare, and of course they find their way into white rooms, the higher quality ones. Some of them tend to get into HEPA filters, but not all of them. And it's very important that we have a uniform standard going ahead, so that it makes the life of the designers simple, and we can deliver to the building owners what we promise them in our owner documents that we prepare. So a lot of guidance is available. Concluding my talk, the first and foremost point, the WHO findings brings out the importance of fine dust, and fine dust has been taken care of in this particular standard, ISO 16890, much more than probably a lot of the standards that I have gone through. And it does a lot of justice to it. ISO and WHO findings are based on PM1, PM2.5, and PM10. Environmental and IAQ standards globally. I've shown you the example of India. I have studied some of the standards which exist in neighboring countries, Middle East, and the parts of Europe. And I guess everyone refers to PM1, PM2.5, and PM10 these days. Get up in the morning, look at the newspaper, and it'll tell you what your yesterday's PM was. Go on to the net. Tomorrow, when we have a lot more of automation going on, probably devices in the building will refer to the net and pick up the PM1, PM2.5, 10 that they expect tomorrow and take action in advance in order to reduce energy and have the right filtration to achieve the IAQ standard and assure the people who occupy the offices that all has been done by HVAC engineers that they could. I'm to say there's always that outside chance that you know upsets the apple cart. But before we have any provision for that, the HVAC engineers need to basically have done everything under the sun that they could do to have these occupants safe, whether in their offices, schools, or any place where people congregate. You can well understand that we all also let out uh, particles which are either solid or sometimes partly liquid. And these are of very fine size. And they need, if we continue to do recirculation, which is a need from energy efficiency basis, we need to have the right part filtration in place going ahead to keep the occupants safe. Next point, filter nomenclature needs to be easy to understand by all involved in IAQ and airside HVAC. Uh, HVAC engineers or building specifiers have lots to go into, and they need one common simple specification or gradation and classification and standard going ahead so that we can deliver what we promise. Uh, with the addition of Eurovent guidebooks and recommendations, the program becomes more holistic and enables engineers to select the correct filters for maintaining desired IAQ levels and with data on energy spent annually to achieve the required IAQ. You will hear a lot about these things going ahead from the experts, and that's my take on it. As Marcus said, we will be doing the panel discussion and taking your questions. We will do our best to answer all queries. Uh, my email ID is also given over here. And if you need to get in touch, you are most welcome, and we'll be there to help you all the way through in order to achieve IAQ standards and energy efficiency. And with that, I would like to thank all the 542 listeners and the panelists who are listening. And this was probably my first international foray. Thank you very much, Marcus, for having me on this program. Thank you.